Let's take a look at another application of a relative extrema of multivariable functions. Please pause the video and read this question and make sure you understand what it's asking. Okay, here we go. We have a one product company. Profit is P in millions. So this is profit in millions. A is the amount in advertising spent in millions. And N is the number of products that you are going to create and sell. And that's in thousands. So we got to watch for that. We want to find the maximum value of P. And they give us P, so we just have to start working then. The first step is going to find all the partial derivatives. So we're going to find the profit with respect to A, and then we're going to do the double partial with respect to A, and then the double mixed piece of AN. So with respect to A, and now we're going to work up here with this function, the first term gives us negative 10, A, and the second term gives us 0 because N is a number. Remember, when we take it with respect to one variable, the other one is considered a number. The third term is going to give us 48. The next term, minus 4n, goes to a number. 2an goes to 2n. And 290 goes to 0. Now let's go ahead and find the second order partial derivative. And this is with respect to n, so with respect to a, because n is a number. And so the first term, negative 10a, goes to negative 10. And the other two terms are both numbers, so we're done. For the next partial, we're doing this with respect to n, so a is a number here. We're going to come back up here again. First term, negative 10a, a number, goes to 0. Second term, 48, number, goes to 0. Last term, 2n, derivative with respect to n is 2. Now let's look at the profit with respect to n, and now that means a is a number. We're going back up here again to the profit function, but now we're looking at n as the variable, not a. So the first term goes to 0. The next term, negative 3n squared, goes to negative 6n. Then 48a, just a number, minus 4n gives us minus 4 as the derivative. Plus 2an gives us plus 2a, and the number 290 goes to 0. So now we can find the double partials. For the first one, we're taking it with respect to n, so a is a number, and we're going to come over here and do this. And so the first term with respect to n is negative 6. The other two terms are numbers, so their derivatives are 0. Now we're going to take the partial order derivative with respect to a, where n is a number, and we're coming back up here to this again. So with respect to a, the first two terms, negative 6n and negative 4, go to 0, and the last term, derivative is 2. So that's it for our partial order derivatives. Here they are all collected together. Notice all of the second orders here are all just a number, so that's going to make it easier later. The second step is to solve the system, and that means we set each of these first order partial derivatives, these guys here, each gets set equal to 0. So negative 10a plus 48 plus 2n equal to 0. And then the next guy, let's go ahead and put them underneath of the like terms. Negative 6n minus 4 and then positive 2a, all equal to 0. Now, if this first guy was equal to positive 10, I could add to 0 and get those two to work for me. So I'm going to multiply this second equation times 5. The first guy comes along for the ride. And the second one times 5 gives us 10a minus 20 minus 30n. And then we, remember, add down because we're solving by elimination. When we do that, these guys go to 0, and we get then 28 minus 28n is 0. And go ahead and add that 28n to the other side. Divide by 28, and we get n is 1. Now remember, the original problem has a and n, so the n is 1 goes in the second spot. Now we have to go ahead and find the a that goes with that one, it has to make this equation true, so we're going to substitute the n in here. So 2a minus 4 times negative 6 times 1, negative 6. So that gives us 2a minus 10. Add the 10 to both sides, divide by 2, and you get 5. This guy is the candidate point. It is the critical point at which perhaps we will find a relative extrema. All that information has been gathered together. Here again is our critical point. So the next thing we want to do is the d-test. And for the d-test, we are looking at the d, and we have variables a and n. So we are looking at p sub AA, P sub NN minus the mixed partial squared. Now again, because these guys are all numbers, we can just substitute in. So we get negative 10 times negative 6 minus 2 squared. So 60 minus 4, which is 56. And 56 is greater than 0. So that means we have a relative max or min. We have to check. So let me scoot this up. Let's go ahead and check the second order, and we're working with p. The second order partial derivative, p sub AA. Well, p sub AA, and I moved my paper up, p sub AA is negative 10, which is less than 0, which means this, which means we have a max. So we have a relative max at our candidate point, which is 5, 1. That's a 1. Let's gather our information now for our final conclusion, because remember, the problem is asking us for the profit and where that happens. So we have to substitute the 5 and 1 into our original equation, and when we do that, we get 408. You don't have to show that arithmetic. Now, remember, our order triple is A, N, and then the actual profit. And A is the amount in advertising, so this is advertising in millions. N is the number of products that we sell, and that's in thousands. This is from the original problem statement. And the last is profit, and that's in millions. So we have to be careful of the units. So there is a maximum profit of 408 million when, and now what is the advertising? What is A? We found 5. When 5 million is spent on advertising and 1,000 items are sold. And that is because our critical point was 5.1. We substituted in to get the 408. And this gives us advertising, 5 million, number of items sold, 1,000, total profit, 408 million. So don't forget to translate that back again. That's it. Hope you're having a great day.